Many of us can relate to interior spaces that are uncomfortable in respect to temperature and glare, where the air conditioning isn't able to keep a space cooled properly, or where you want to put on your sunglasses. As you are aware, daylighting isn't about providing the most amount of light possible. It's about balancing the right amount of light for a particular space. When I get a phone call asking if it's okay to put an aftermarket film on the glass of an existing building, I know that the correct daylighting balance was not achieved in the original specification. Comfort, energy efficiency, and aesthetics may all be obtained with the right glass design.
Daylighting is one of the things about architecture that most fascinates me. It's very important to understand in designing with daylight where you want to welcome daylight and where you want to very carefully control and filter that daylight. Well, I've been involved in use of daylighting in architecture for well over 30 years. And one of the things I've learned that really at first surprised me was that most students, most laymen, in fact, many architects to this day, still assume that letting the maximum amount of daylight into a space is the best way to daylight. And in fact, that's often the enemy of good daylighting. Daylighting is really about contrast, about balance, about control, about filtering. And I found that if we carefully specify the products that go in our buildings, we can be much more successful in how we do that.
You know, as architects, oftentimes we're faced with many different challenges as we're working on a project. And with the advent of sustainability and LEED coming into play these days, it becomes even more important to pay attention to all the little influences that enter into a project and helping to make design decisions. And one of the aspects with LEED is trying to come up with ways to balance things like energy efficiency and daylighting inside a building. Both of these things are very important in a project. What we wanted to do is make sure we didn't get daylighting too high inside the building, because then you create a different kind of problem with glare, with discomfort from glare, with computer screen glare, glare to the human eye, things of that nature that makes it much harder to work. Or try to find the right balance of daylighting coming into a building and the energy that the building consumes. What we found as we were going through this, it seemed like for our project, the best balance was probably somewhere in the 28 to 35% range. That light transmittance also allowed us to get a good balance with energy consumption in the building, with good U factors, with good solar heat gain coefficients.
Seemingly every project that I work on reopens the debate about what that optimal visible light transmittance level is, but we've discovered over time that there are some things that we can reliably fall back on that seem to help us a great deal. Silkscreen is one of our favorite methods to use because it seems to allow us to keep a higher level of visible light transmittance through the glass and a warmer light coming into a space, but still mitigate the effects of glare and solar heat gain. So like at this project, for example, we used a silkscreen frit in the lobby here with a very fine pattern, which doesn't interfere with the views, but it allowed us to have a much clearer glass. And the combination of that with a low E coating on the number 2 surface allowed us to experience or appreciate a 30% enhancement of the solar performance of the glass, which is really great.
As an architect specializing in daylighting, one of the things I'm really fond of is to use a variety of products to achieve our daylighting goals. I've learned through experience that if I try to do everything with just one particular product, it actually limits my range of solutions, and I don't like to do that. So one of the things I think is really intriguing about this particular building, even this glazing has 3 different varieties to help us achieve those results. So for example, we have very different levels of light transmission depending on which elevation the building we're on. One for east and west, one for north, and a different one for south.
I do daylighting consulting with architects. I do lighting measurements, lighting calculations, and consult with them on the best way to bring natural lighting into a building. We're recommending a much lower visible light transmittance today than we would have before.
As you can see, the light in the area we're standing in is very comfortable, it's very clear, it's bright. 12% of visible light overhead is a huge amount of light. Many architects today go overboard in sort of the desire, I believe, to show their product off or show the building off with too much light transmission. In a vertical plane, you want to stay below 40% visible light so that you can still see your computer screen and still function. You don't need your sunglasses on. Depending on what kind of space you're trying to light, what you're going to do in that space, 10 or 15% of light can be a huge amount of light in all actuality.
One of the main features of the building, you can see really from the outside as well as from all the floors, is the exterior glazing. And we have a really high window to wall glass ratio, which was a good challenge because we also are a LEED Platinum building. So one of the things we did with the glass and with the glazing was we really wanted to balance both the daylighting and the sight lines, views, which is really important downtown, with the ability to maintain that high energy efficient standard. So as we were picking the glazing and designing the glazing, we ended up with, for our high impact blue volumes, we have a reflective blue coating on the glass, which has an 8% light transmittance. And then we balance that against the gray glass, which has a low E coating and is about 23% light transmittance. So with the combination of those two, we were able to achieve the daylighting that we were looking for, this views for 90% of the spaces, as well as balancing that with our energy requirements.
When defining the specifications for the glass design, there are several options available to you. Incorporating a high-performance coating is often the primary attribute. Tinted glass substrates and silkscreen patterns may also aid in controlling glare and managing heat gain in buildings. We like to refer to this balance as right-sizing the light and energy management for the application. We can help with recommendations to right-size the glass for your next project.